Our next topic will be the assessment of excess power for different scenarios of wind power extension in Germany. And for that, please welcome with me a scientist from the Forschungszentrum Jülich, Mr. Martin Robinius.
Yeah, thank you. Thanks for this kind introduction. I'd like to welcome you all here to my presentation. What I want to say you in a couple of minutes, first of all, is what is power to gas, a short introduction. Then I want to show you some of the results of our electricity market model, and then a few selection of results. First of all, why I'm standing here, something telling about the renewables or wind power when we are here at the area about hydrogen and fuel cell cars and everything else. And the answer is simple. It's called the concept power to gas. Here is the schema where we can see where the future could look like. For example, we have the renewables like photovoltaic or wind energy. We're producing a high surplus energy, and the question is, what can we do with this energy? And with this energy, for example, we can produce hydrogen by using electrolyzers, and then we have three possible options to use this hydrogen. First of all, we can use it directly in a storage system or in a hydrogen pipeline grid to store it or transport it, and then we can go to, for example, fuel cell cars. Other way is to feed in Germany. It's about 5% in the natural gas grid, and another possibility is then to produce methane by using CO2 and the hydrogen, and then actually we don't have any limits in the natural gas grid. As you can see here in our institute, we make a scenario where we use, for example, a hydrogen pipeline grid for Germany, which we can see here, which cost about 6 to 7 billion euros for a transmission pipeline grid, and about 13 to 19 billion euro for a distribution grid. And why should we use something like a hydrogen pipeline grid? And the answer is, you can see here. For example, what we're paying right now, pre-tax for natural gas, is about 2.5 to 4 cents per kilowatt hours. Then these are now our target costs. When we use electrolyzer and feed the hydrogen directly to the natural gas grid, we are already at 15 cents per kilowatt hour. If we want to go a step further, for example, we produce from the surplus energy, hydrogen, and then we go to natural gas, we can see here we end about 23 cents per kilowatt hours. So you can see we have here a huge difference between the target cost and the actual cost. And as we can see here right now, at the gasoline pre-tax, we pay about 8 cents per kilowatt hours. In Germany, we have a huge amount of taxes on top of this. And with the efficiency step from the fuel cell, we can say here we are about 16 to 22 cents per kilowatt hours, where we can say to the customer, all right, can you pay this? And the customer wouldn't recommend or wouldn't see anything about this drop in the cost. And here with the 20 cents per kilowatt hours is already included 84 gigawatt electrolyzers and a complete hydrogen pipeline grid. You can see here in this picture that we not far away from this what will be really a cost-effective scenario. Then the question is, now we could see, all right, it is a smart solution maybe to go with the surplus energy to electrolyzer and produce hydrogen, and then go to a hydrogen pipeline grid and use the hydrogen in the fuel cell. But the question is, where should someone build the electrolyzer? And therefore, I can show you here an example where we can see where and how high is the excess power. First of all, I have to show you a slide about how we can really model or calculate the excess power. It's called residual load. First of all, you have the normal load. For example, if we put some light on, the load increases. And the question is, after the load, we we use the renewables, and then what it's after the residual load, therefore we have to go with conventional power plants. That means if we have a negative residual load, we have surplus power, we can use it in electrolyzers. If we have positive residual load, we have to use controllable power plants. Here I want to show you how the load in Germany looks like. We have, for example, the main spots with a high load are here in North Rhine-Westphalia, in Saarland, or even in Bayern. And the really low load is actually here in the east part of Germany. And you can see here the measuring about a week, that you can see really this load really changes from hour to hour. The next step is I want to concentrate only on wind energy. We did estimation and scenarios for all renewables, but I want to show you just the wind energy, how it interacts. Therefore, we built a model, and to know where we have this wind power, first of all, we have to see where can we build windmills. And therefore, we can see, for example, here, where we use distance that are normal, for example, for living areas, and then we get about 30% of Germany, what's really from the area really usable for the wind power. Another scenario here, I would call it the Horst Seehofer scenario. It's a famous scenario in Germany where he wants to have the distance really large between the living areas, and you can see with this few changes in the assumptions, you only get nearly 5% of the area in Germany. You can see here how big the changes in the distances are an impact of the renewables or the wind energy. Then we use the weather data from the German Weather Institute and also cost assumption and different power curves, where we then can optimize the installed capacity, for example, by cost or by full load hours. The result interpretation you can see here. I would mention published work from us, where you can see later on the internet, on the slides. But first of all, you can see here the green dots are actually the cost optimal places for the wind energy, and the black dots are actually the places in 2014, and that's here you can see that there's really a difference between the cost optimal places and the real places that says nothing else than, all right, we built the windmills right now not on only cost assumption, but only on, I would call it, the federal stage goals, and produce it in each federal state. Here what you can see right now is we make a scenario where we installed a big capacity of wind with about 141 gigawatt, and we used the load from 2030. And you can see here, without using a grid or even offshore, we have a huge amount of surplus energy here in this area. It's a green one. And still we have a huge amount of positive residual load in, for example, North Rhine-Westphalia. And as you can see here, we have also a huge impact on which month we are. For example, we have here in the winter date, we have a high surplus. It's going low in the summer and then high again in the winter. And you can see here, for example, in June, we have in Lower Saxony about 4.5 as much that we had before. So that means that we have a huge surplus energy regarding which month we are or which wind scheme we are in. So to summarize this again, I want to show you before that we have here for a really changeable renewable. That means nothing else that the electrolyzers have to be really concentrating of the fluctuating energy, and that we have therefore, as I mentioned here, places where the electrolyzers could be. This means nothing else when we integrate here, for example, the electrical grid, that this amount of energy for sure will be lower, but with using also the offshore energy, this will be increasing again. And therefore, we have here in this area also the salt caverns, where we can storage hydrogen and then can go with a hydrogen pipeline grid to areas where we, for example, needed it. And this is, for example, places with high cars in use, for example, here in North Rhine-Westphalia. And then again, this shows also, I would call it the three federal states that are the winning states if it's going further like before in Germany, with the only onshore installed capacity are raising. For example, we had last year about 4 gigawatt installed capacity more than in the year 2030. So we are right now about 40 gigawatt onshore wind energy here in Germany. And that shows actually where how we increase the onshore installed capacity. And these are I would say in future also, if we don't change anything in the revenue stream, where we have this huge amount of surplus. They three are all in the north region. That means this amount of 4.5 was doubled from June to December, not only be possible for one federal state, it's possible for all three of them, as you can see here. That means that if you add all these three surplus energy, you get a knowledge about which amount of energy we are dealing here with and how we have to use this real amount of energy. And therefore, again, I would suggest that we can use there the electrolyzers and produce hydrogen with it. To summary it again, what was the scope of this presentation? So first of all, I showed you short what does the power to gas concept means. Again, power to gas concept means that we have the surplus energy with is generated by the renewable energies, and then therefore we use the electrolyzers and produce hydrogen with it. Then the hydrogen using in the transport sector I showed before is one cost economically model or one scenario where we really can use this hydrogen in a good way. Therefore, our institute developed a hydrogen pipeline grid and also a scenario and make cost assumptions to see where we go in the future and how much amount of energy do we have there. We built therefore an approach that not only considers the electrical load in the 11,000 municipalities in Germany, but also takes every renewable energy into account and a different installed capacity scenarios. Here I just showed you the wind scenario. We also integrated the EEG, that is in Germany the renewable energy law, where we can see a revenue stream for the renewables. Furthermore, I showed you a few selected results. If you are further interested, you can go to the published work or even to the presentation. And what we can see is in Germany there wasn't so far a cost or profit optimal installation of the wind power. It was more driven, for example, of the goals of each federal state. Would it be a cost-effective installed capacity? We have the regions nearly only in the north of Germany, because there we have high wind speeds and a lot of full load hours. Then, if we would install, for example, a future only full load hours driven system, we could increase the full load hours by about 800 hours. And again, I want to say, if you are interested and see further results of our institute, we also modeling electrolyzers, or we have a big electrolyzer at our exhibition thing. You just go, it's not a technical forum, it's a public forum, and you will find us directly there. Okay, thank you for your attention.
Thank you for this interesting presentation. Now we have some time for, I can take a few questions from the audience right now. You can just raise your hand and I will come to you. Yeah.
Oh, My name is Yoshiki Skeyas from Japan, and I'm working for Hitachi Zosen Corporation. And I joined your presentation in halfway, so I would like to ask you some about the EEG, especially policy incentives for the power to gas, and because I have no knowledge about the EEG and a possible incentive scheme for power to gas, do you have any idea on how this EEG incentive will progress to drive the power to gas in Germany company?
Yep. That's a really good question because in Germany I would say we have there a little problem. For example, in Switzerland, if you pay, if you install an electrolyzer on the places where you have surplus energy, you don't have to pay for the grid fees, for example. And here in Germany it's quite different. So I would say to really think about power to gas concept, the government has to say something at least in the start of this technology. How can we make a few things that it's really for the I would say for the industry, it's a good way to build up some systems to get used to the technology, to know where are the good parts, where are the bad parts, and then later on we can, I would say, go out of this regime where we get fundings or something else. But I think in the beginning we should maybe go on a concept that's related to Switzerland, because I think that's a really nice idea of them. So.
Thank you for this interesting question. Now, we all know that the hydrogen fuel cell industry, things have been changing, we are getting to the market, and for that we will hear another topic this afternoon at 3:40 at the public forum around the corner, same speaker, and the topic will be preparing the electricity market for integrating large quantities of renewable power. Thank you very much.
Thank you. Thank you.
And we can visit you at booth number?
Yeah, it's directly at the public forum. You will see it directly there. It's just straight down here.
D68.
Yeah.
Thank you very much.
Thank you.